Hello and welcome. Let's work about few capacitance problem. And we have a very special and very common problem at our screen that requires to find the capacitance of a pair of metal balls. And you can read the statement that says determine the capacitance C of a system of two identical metal balls of radius r located at a distance L much greater than r from each other. So we need to find its capacitance and we can do it easily. First, let us provide the charges to the balls, identical charges but opposite in sign. Suppose we provide a charge plus q to the left ball and minus q to the right ball. And since the balls are located at a large distance from each other, we can neglect the redistribution of charges on the balls due to electrostatic induction and assume that the charge is uniformly distributed over the surface or surfaces of the balls. Now I would like to take a x-axis just in this direction with the origin of the x-axis at the center of the left ball, the origin of the x-axis, and now we need to find the electric field at a point on this x-axis. Suppose the point is this and this point has a coordinate x, that means it is at a distance x from the origin, and let us find the electric field at this point P. And we can use the superposition principle. The left ball produces an electric field in this direction and the right ball also in this direction, but the magnitude of electric field will be different because distances are different, and we can write the electric field at point P as Ex, and that will be equal to simply 1 upon 4 pi epsilon naught, and due to left we will like to write it q upon x square, and due to right it will become q upon simply the distance L minus x. So it can be written as. Now we are going to find the potential difference between the surfaces of the balls, and to find the potential difference we will simply integrate the electric field between them, and electric field is already written, so the expression for potential difference can be simply written as, I often write U, capital U, as the potential difference. You can write V. I wrote some book, in fact I read some books in which potential differences were written as U, so I can write it as difference between the higher potential and lower potential, and it will be written simply as plus 1 upon L minus x square dx. And since we need to find out the potential difference between surfaces of the balls, so we can put limit here as R to L minus R, and you need to integrate this thing to get the potential energy, and you can write it as Q. You will find ultimately that this integration becomes something like this. Yeah. And now by definition we can find the capacitance of the system of these two balls, and this will be nothing but Q upon the potential difference, charge Q to any one of the capacitor plates, and then we can write capacitance as Q upon U. And if we write all the things we got here from our calculation, we can simply write it as 2 pi epsilon naught R L minus R upon L minus 2R. And if you like to write them, you can write them again as that becomes find out L from both numerator and denominator, so that you can write it as numerator side as 1 minus R upon L and denominator as 1 minus 2R upon L, and L gets cancelled out from both numerator and denominator. And if you want to do something more, you can also write it as 2 pi epsilon naught R 1 minus R by L multiplied by 1 minus 2R by L raised to minus 1. And if you want to use the binomial expression for 1 plus x raised to n is binomial, it is a kind of binomial approximation where we simply write 1 plus x raised to n as 1 plus nx. And of course here x is less than 1, much less than 1, and here it is the case, our x becomes R by L, and since R is much less than 1, so R by L will be much less than 1, and you just spread the expression and justify it, you will get your result that will be approximately equal to 2 pi epsilon naught R. Up to first approximation it becomes 1 plus R by L. And if you want to go further and R by L is very close to 0, it is not just much less than 1 but very close to 0, then in case you will get the results as simply as 2 pi epsilon naught R, that is the capacitance of an isolated capacitor, a spherical, of course a spherical capacitor. So the result is true, but it is something like that we got as a result for this problem. And thank you very much for watching.